Hi, welcome to this part. Alright, this is part 2 of lesson 4/5. Okay, about gradient. Okay, so this part of the lesson we're going to talk about how we're going to find the gradient. Alright, so now what is defined as a gradient or the steepness is basically refers to the change in the number of units. Okay, what do I mean? Okay, now if you see this like just now that the beginning of this lesson 4/5 on page 12, okay, the previous page. Now AB, okay, the steepness of it, right? Okay, how do I measure the steepness? Okay, do I measure by the length of it, how high it goes? Not necessarily true, right? Because let me give you an example. If I have another line, okay, another line that is going from A to, let's say, this point here. Okay, let's say I have another line here. Okay, let me call this point D. Alright, so AD. Now, AD versus AB, which line is steeper? Line AD, correct? AD is steeper. This line that I draw is steeper. However, B ends here and B ends here. Point B is higher. So it doesn't mean that the one that goes higher is the steepest. No, it depends on the length of the line actually, right? Depends on the length of the line. Okay, but I do know what you mean, alright, about that. Right, so the steepness of it is basically the formula here is vertical change over horizontal change, or some of you may have known is basically we call it the rise over run. What is the rise? Rise is basically the vertical change over the horizontal change run, right? Rise over run. Okay, now so how do you measure that? What does it mean by gradient, or how do I remember gradient? Now it's basically at A, if I change a horizontal distance, okay, if I move by horizontal distance by 1 unit, okay, by 1 unit, what is my change in height? Okay, if I move it by 1 unit, what is my change in height? Right, so meaning if I go back to page 12 of the note, so these 3 points, right, A, B, B, C, and D, right, you see from point A, I move by 1 unit to here, right, I move by 1 unit. What is my change in height? For D is this much, for C is this much, for D is this much. So basically, the higher it is, the bigger the value it is. That means the steeper it is, right? So that is why you have to take the vertical change, all right, divide by the horizontal change. Okay, so gradient, does it have any unit? So gradient does not have any unit. Okay, gradient does not have any units. It is basically a ratio number, alright, of a vertical change over horizontal change. Now let's take a look at example 1. Right, so over here, now so the gradient of this line, now so along the graph, right? Okay, along the graph, now if you look along the graph, you will definitely find a point whereby it is very nice at the crosshair. What do I mean? Okay, over here, let me zoom in a little. Okay, what I mean is you will want points to be like here, like this. You want points to be like this. Alright, you want points to be like this. All these are very nice points. Okay, all these are very nice points. Points in the middle is something that I do not want, because yes, the y coordinate I can tell is 4, but for the vertical one, sorry, for the x-axis, I do not, it's not very precise of whether does it intersect here or directly in the middle. It is not very clear. So such points, avoid them. So you go along the line, you choose 2 points. Okay, choose 2 points. After that, what do you do with it? You form a triangle. Just use dotted line, like what I'm doing here. Form a triangle, and then I note down the height and the base. Okay, some basically call it the height over the base to find the gradient. So the height of this triangle, it is not 5, it is from 3 to 5, meaning the height is 2, only 2 units. Okay, only 2 units. And same thing for the base, is from 1 to 2, so the base is 1 unit. Right, so based on this, my gradient, okay, gradient, use the symbol M. Okay, gradient, this is my gradient. Okay, the acceptable symbol is M. Okay, small letter M. So my gradient is rise over run. Height over the base. And because it's going upwards, it is positive. So simplify, my gradient is 2. Okay, now there are some of you may be thinking, okay, what about the other points? Okay, what happens if I take the other points? Well, if I choose another point, so this one I choose this point at 3 and 5, right? So I can choose another point. So maybe I want to choose 5 and 7. 5 and 7, same, you see? So gradient is the same. So what can you deduce about this? Say 5 and 7, same point, gradient. Just on 3 and 5. Even if I choose 1 and 3, it's the same, right? The same, right? The same. In fact, anywhere along it, if I'm able to get a correct reading, okay, the 1 and the 2 is always vertical and horizontal, right? So this shows us that for a straight line, the gradient is constant. Right, for a straight line, a gradient is constant. Okay, this is basically what it shows. Okay, for a straight line, a gradient is constant. Okay, so do try the questions. Okay, at the back, right? So this one, okay, try. Okay, try first. Okay, you can pause the video and do first before viewing it. Okay. Now, so over here, same thing. Along the line, you see, choose 2 points. So I can choose this point, and I can choose this point. The triangle already will form. It's on the axis. So my gradient, now, first thing, this line is going downwards. Okay, this line is going downwards. See, it's going downwards. Left to right is going downwards, so I add in a negative sign first. Okay, then a fraction. The height is 6 units, the base is 2 units. Right, press a calculator to simplify. This is my gradient. It's going downward, so it's negative. And 3, why 3? Because at 0, it's at 6. At 1, you see it is at 3. After I move 1 unit, when I move 1 unit to the right, my change in height is negative 3. Okay, remember the definition of gradient. So when x equals to 1, it is at 3. When I move another unit to the right, the height goes down by another negative 3. So every 1 unit I go, it goes down by negative 3. This is basically what gradient means. Right, thank you for paying attention. Right, we may move on to the practice questions.